Solve by factoring. This is section 4.4. This time a is not equal to 1, so we're going to have a coefficient on the first term. This is where it's very important where you run that test to see if it can be factored. And it's also very important that you look for the greatest common factor of all three terms. That's always the first step in factoring, and that's the one that gets forgotten. Okay, but so just starting with that, look for the greatest common factor. Okay, I don't have one for this first example. Okay, so carry on. 7 times 3. Okay, 7 times 3 is 21. What are the factors of 21 that'll subtract to 20? Okay, well that's 20 and 1. Oh, nah, 21 and 1. I'm out of my mind. The third term's being subtracted, so we have a sign issue that we have to deal with here. We have a negative here. 21 is greater than 1, so the 21 is going to get the negative. Now, what we're going to do to find out our factors, we're going to have our factors here. In order to find out what these are, we're going to divide this by 7. Okay, the first term is 7, so we're going to divide this by 7 and simplify anything that can be simplified. So negative 21 goes, 7 goes into negative 21, negative 3 times, that's going to be 3 over 1. This is going to stay 1 over 7. Well, guess what? These are going to be your factors. Your x is going to go with the denominator. So we've got an x minus 3 and a 7x plus 1. Okay, check it. 7x times x is 7x squared. Do your outers and your inners. X times 1 is 1. Negative 21, negative 20x, and then 3 times 1, negative 3 times 1 is negative 3. It worked. Okay. This method, guys, takes the guess and check out of it. If you follow along in your book does guess and check. I don't want to deal with guess and check. We're just going to factor, period, and get it right the first time, every time. All right. Do the next one. Greatest common factor. Oh, there isn't one. Okay, so now we just multiply. 3 times 12 is 36. Okay, factors of 36, that'll subtract to 5. Okay, it might take a little bit of thought. Oh, 9 and 4 came to me just that quickly. 9 and 4. Now, we have a subtract here, so that means we've got a sign issue here. So let's look at the middle term. The middle term is being added. 9 is greater than 4, so the 9 is going to be positive and the 4 is going to be negative. Because the greater of these two is going to get whatever this sign is. Now, divide by 3. Okay. If you want to, put an x with that so that you know that the denominator is is going to go with the x. Okay. Simplify anything that can. This one can be. This is going to be 3 over x, and this will just stay negative 4 over 3x. And so we've got x plus 3 and 3x minus 4. Check it. Outers, inners, last. Okay. Alright, we're going to keep factoring. Okay. Greatest common factor, look for that first. I don't see one. Now we multiply the first and the last terms. Well, 5 times 3 is 15. Factors of 15, that'll add to 16. Well, that's easy, 15 and 1. Divide both by the 3 if you want to throw an x on there. That helps remind you that that's going to go with the x in my binomials. Okay, simplify. This is going to be 5 over x, and then this will be 1 over 3x. So we've got x plus 5 and x plus, or 3x plus 1. Check it. Okay. And next one, greatest common factor. There isn't one, so we multiply. 4 times 2 is 8. Factors of 8, that'll add to 9. Well, that's 8 and 1. So we're going to divide those by 4. Okay? And make your binomials. This one will simplify. We're going to have 2 over x and then 1 over 4x. So we've got x minus 2 and 4x minus 1. Okay? Notice on these two problems, the third term was being added for both, so I didn't really do the sign thing. This one's greater than that, so we don't deal with that. If the third term is being added, then both of your binomials will have whatever this sign is here. Okay? All right, factoring. Oh, look, these should ring a bell. This is the special factoring patterns. Okay? 16 is actually 4 squared. 1 is 1 squared. So this is the difference of two perfect squares. The difference of two perfect squares. Okay? Recognize those right off the bat. If you don't know your perfect squares, learn them. It'll help you so much in the long run. This is going to be 4x plus 1 and 4x minus 1. Just that quick. Same thing here. 36 is a perfect square, so it's x squared. 9 is a perfect square. They're being subtracted. Oh, difference of perfect squares. It's going to be 6x plus 3, 6x minus 3. Okay? If you learn those special factoring patterns, it'll help you so much in the long run. Okay. Now, factor. Starting with greatest common factor. There is one, 3. So when we factor out a 3, that's going to leave us with x squared minus 8. Okay? 8 is not a perfect square, so I don't have a difference of perfect squares. I've just got 3 times x squared minus 8. We're done factoring that one. Next one. We're going to factor, let's see, we've got negative 16x and 12x. Let's factor the negative out with it. We've got 16 and 12 have a common factor of 4, and x squared and x have a common factor of x. So negative 4x is what we're going to factor out. When we divide negative 16 by negative 4, that's going to leave us with positive 4x, and then minus 3. Okay. If you don't remember to factor out the negative, that's okay, but it'll help sometimes because sometimes you might end up with the difference of two perfect squares if you factor out a negative. Next one, let's factor out 3. We've got 2x squared plus 11x plus 12. Okay. Now let's see if that will factor anymore. Multiply the first and the last terms. 2 times 12 is 24. What are the factors of 24 that'll add to 11? Oh yeah, we just saw it right here, 8 and 3. So yes, this will factor. So let's continue with our factoring. Now we're going to divide these both by 2. Divide them by 2. This one will simplify to 4 over x. And this one does not, so that's going to be 3 over 2x. And I know I'm running out of space. So sorry. So now the 3 was factored out originally. Now it's going to factor to a product of binomials. We're going to have x plus 4 and 2x plus 3. Okay, that's how it factors. X plus 4, 2x plus 3. Now, why are we doing this? We're doing all this so that we can solve them. So let's solve some. Multiply 3 times 8. 3 times 8 is 24. Factors of 24 that'll subtract to 10. Oh yeah, 12 and 2. Okay, subtraction, since 12 is bigger than 2, 12 gets this symbol, which is plus, and then the 2 is going to be negative. Divide both by 3. if you want to throw the x on there so that we know that that's the coefficient on the x for our binomials. This will simplify to 4 over x and negative 2 over 3x. So there's our factoring. We've got x plus 4 and 3x minus 2 equals 0. Set each factor equal to 0. So x plus 4 equals 0. 3x minus 2 equals 0. X equals negative 4. 3x equals 2. X equals 2/3. Here's another one to solve. It looks kind of terrifying, but it's not too bad. First thing we have to do when we're solving these things is to set everything equal to 0. So we're going to have to move this stuff over here and combine like terms. So we're going to subtract x and subtract 8. Subtract x and subtract 8. That's going to give us 12x squared plus 6x minus 6 equals 0. Now we start our factoring. Greatest common factor. We have one. Very nice. Factor out of 6. It's going to be 2x squared plus x minus 1 equals 0. Well, you know what? Since we're solving, we're just going to divide by 6. Well, what is 0 divided by 6? Oh, yeah, 0. So when we divide by 6, we get 2x plus x minus 1 equals 0. Now you factor, we can still use that other factoring method. 2 times 1 is 2. The factors of 2, that'll subtract to 1. Oh, that's going to be 2 and 1. And then since 2 is greater than 1, 2 is going to get the positive and the 1 is going to get the negative. Divide both by 2x because that's the first term. Should be a squared there. And this is going to simplify to 1 over x, and this will be negative 1 over 2x. So there's our factors. X plus 1, and 2x minus 1 equals 0. 2x minus 1 equals 0. That's where we get our binomials. Set each one equal to 0, so x plus 1 equals 0, x equals negative 1, 2x minus 1 equals 0, 2x equals 1, x equals 1/2.